Hello, everyone. Welcome to my talk about building the world's fastest Game Boy emulator in modern C++. And let me click this so this will work. Okay, about me. When I'm not flying a starship, which is unfortunately most of the time, I wear Star Trek pants to compensate, and I teach. Mostly C++, some algorithms as well, computational system fundamentals, and also some retro console programming, which is something that kind of co-evolved with this talk and the matter we'll discuss. First question about this kind of talk, but why? Why build the world's fastest Game Boy emulator in modern C++? That's a mouthful too. Well, allow me to answer that question in several parts. Why modern C++? Well, look around, right? We're here. This is what we do, right? And building an emulator, it's a fundamental step in becoming a real programmer. If you want to understand something, you build it yourself. The previous speakers were alluding to something like that, very explicit about this. If you build an emulator, it will make you a better programmer because you will understand hardware better. Okay? So why the Game Boy? Well, first of all, Game Boys are awesome, right? They were released in the late 80s, and because of this, everybody knew how to build good 8-bit machines. They have a very clean, very well-matured design, and plenty of them were sold. Plenty of them were sold, that means well, there's a lot of stuff out there about it. People forget how shitty the original screen was, right? Price was what drove it, right? People's memories who played the original one, if you find them, the screens have not gotten worse. You have rose-colored glasses about the past. The resolution is 160 by 144, which is a stamp on a modern screen. You have 8 buttons, which conveniently should be a byte, but it's not. Stereo sound, if you use the headphones, you don't need a special adapter to use headphones. It has a mono speaker. Emulating the Game Boy is easy. If you ever write an emulator for a real system, this is probably the one to do. Look, this is just a list. Oh, nobody's seeing my slides, but I'm seeing them on the... Yeah, but I'm seeing something else on the screen. Okay. Oh, wow. So I was just talking, and that's why the Star Trek joke didn't land. Ah. I thought it was me. Yeah, let's give it some time. I see the slides appear correctly on my display. Good for you. You can all come and sit here. It'll be a special experience. It works on the screen. Yeah. Is there anything I can do? Yeah. Okay. Well, I can talk a little bit about the stuff. Yeah. So I was going to point at the screen. In a bit, you will see a slide where I've listed most of the Game Boy emulators I have found. There's a whole list of them. Also, it's probably the best documented hardware there is. If you develop an emulator or a game for the Game Boy now, you have access to better documentation than the people who did it as a job 40 years. Oh man, I'm old. 40 years ago. If that fails, right? If you write it and it's shitty, and we all love writing tests, right? Writing unit tests, we know we have to do it, and we love doing it. The Game Boy has plenty of test ROMs. So you write your emulator, instead of a game, you plug in the test ROM, and it will tell you what's wrong with it. So you don't have to write unit tests. How cool is that? Super cool. No, I'm lying. I love writing unit tests. It's my favorite thing. Every morning I think, yes, unit tests. Okay, so still no slides. Well, until I get to code, that's gonna be funny. Another advantage of the Game Boy is it has a huge game library. And when I say huge, I mean for that day and age, the Game Boy itself had officially released over 1,000 games. The Game Boy Color had another 600 almost released for it. 30 of those were backwards compatible. Yeah, Nintendo's always been, there's kind of backward compatible, some of them, but some of them are not. Yeah, they didn't start this story with the Switch too. Also, there's a very active homebrew community, so you can actually run new games on your emulator you write. Huh? Eat your heart out, Game Gear. Yeah, yes, the old Sega versus Nintendo wars, they are still not over. From my cold dead hands. Now I show a beautiful picture of a book I recommend called The Game Boy Encyclopedia, written by Chris Scullion. I bought it, it's great. I'll just continue since otherwise my time is running out. I just told you a huge game library. It's also a tiny game library. What, Tom? Are you getting Alzheimer because you're sold? No. No, it's a tiny library in bytes. The entire Game Boy library is about 800 megs. All those games, all over 1,000 of them. If you add all the Game Boy Color ones, that's 1.5 gigs. Those two together, that's a lot of entertainment and not a lot of data by today's standard. So, great stuff. Let's touch CP for good luck. Interestingly, compatible parts are still being made. If you have a broken Game Boy, you can still have it fixed. It's easy to yourself. Aha! Ha! And they said I was crazy. Let me show you the beautiful slides you have missed. That was for the Star Trek show, right? When I don't fly a starship. Thank you, thank you. Thank you, thank you. So, look, my beautiful but why animation. So yeah, shitty screen. It's worse when it starts moving, then it gets blurrier. You mean blurrier than this? Yes, blurrier than this. These are some of the most famous emulators. There's plenty more. You can see it's on all the systems. Normally, I forgot them in the hotel. I have 2 copies of Tetris, which is a game we'll talk about. Just so please don't sue me, Nintendo. Those technical documents are all available online. They're great. Test ROMs, as I said, you don't have to write your unit tests. Look on Homebrew, how many games are being developed. This is that beautiful book. It's truly a beautiful book. It's something very fun to look through. The size, yes, these are the new parts you can still buy. I'm not related to any of those companies. The thing on the right, you can really replace the entire interior of your old Game Boy with new parts. This is the Revision 4 motherboard. Why do I show this? Look how effing simple this is. There's a CPU sitting there, and there's some RAM sitting there, and then some stuff for the audio, the power switch, some contrast control, some sub-connector, and then a big cartridge connector. That's it. That's how clean the design was. Ahead of its time also, because it's a system on a chip. The CPU is a Sharp LR35902. It's Nintendo's interpretation of something like a Z80. It has an exact frequency. You can see it there, I will not pronounce it. You probably recognize that number. Who recognizes that number? Few of them, it's a power of 2, right? Programming in it is nice. You don't do I/O port stuff. Everything is memory mapped, which is nice. We like this as programmers. It has the registers from the 8080. It has Z80 extended bit manipulation stuff and some extra stuff. Here you see a block diagram of the entire thing. As you can see, the system on a chip contains what they call the picture processing unit. We would call that a GPU nowadays. The processor, some built-in ROM, which is actually comparable to a BIOS, some APU, which does the audio, and that's it, right? It's easy to understand. You can imagine it's quite easy to implement as well. Memory mapped, well, you have 8 kilobytes of RAM. If you think that's not a lot, well, that's 4 times as much as the NES. So yeah, 8 kilobytes of video RAM as well, and everything is mapped into one uniform memory space. There are some small weird things that you have to pay attention to. But when you do your first emulator, don't worry too much about these corner cases, right? The test ROMs will tell you afterward. If you want to know everything about the Game Boy, there's something called the Ultimate Game Boy Talk. I know you're disappointed now. You thought this was it. No, this is not the Ultimate Game Boy Talk. This is the average Game Boy Talk by some guy. But I recommend it highly. It's very good, very energetic. Highly recommended. Now, it's simple, but I can't show you this full source code of a Game Boy emulator in 1 hour unless we just spend this time scrolling to the code and maybe do a code review together. Well, no, that's not very conferencey. Let's think it a bit. Why is it so much work? Look, this is the instruction set. These are all the byte codes. Don't worry if you can't read them very clearly. The colors all mean something, right? And there's something in these states and some mnemonic and flags that are affected. One important part, if you look, let me laser point, there is some instruction here called prefix. It's instruction CB. The instruction CB is how they extended the instructions. If you start with CB, then it opens another page with another 256 instructions almost, right? Yeah, there's some codes that are not being used. If you try to call those, the system crashes, which is a good design. I'm looking at you, 6502, right? Somebody sends a wrong bytecode, you should crash, not just do some random shit that, of course, somebody will then use in their game. If you're writing an emulator, one of the first questions that will show up is, are you doing T cycles or M cycles? Tick cycles, also called machine cycles, emulate everything that the Game Boy does at the full clock frequency, but you could do M cycles. M cycles are nice. Everything takes a multiple of 4 M cycles. There's 4 T cycles per M cycle, so there's 16 of those for an instruction. And for some very tricky to emulate games, this is important. I hate it with a passion. If you write an emulator and it runs Battletoads, congratulations, you made it in life, right? They're doing nasty stuff with timings and interrupts on lines and pixels. And great, it's a great game. A pain in the something to emulate. This is the other page of instructions. So as you see, there's another 256 to implement. That's rounded bits. That's about 512 instructions. That's a lot of stuff to show you. So I need some kind of toy example. We're not going to do the whole thing with all the corner cases today. I need a toy example. What to pick? I need to pick something that everybody knows and that's not too hard to simulate. Anybody got any idea what we're going to try to be making? Yes! Pong! Good try, but no. It's a bit slower than I had hoped. Look, I'm making something. Nice, right? Thank you. There's actually a site that does this for you. So if you want to impress somebody, and actually when you make it on the site, you can set the speed. When we export it as an animated GIF, the speed is standardized. So that's why it's so slow. Okay. So, right, why choose Tetris? Well, this is the time when I normally bring out my 2 copies of Tetris. I have them with me in the hotel. Everybody owns Tetris. It was bundled with the Game Boy, at least in the beginning. So there's millions of Tetrises out there. They're very cheap if you want to buy them. I own several because I will also own several Game Boys. That's a good reason. The reason I show them normally is, please don't sue me. For people the 2 people here who don't know what Tetris is, are there people who don't know what Tetris is? That's what I thought. Yeah, some of these slides I used to present the project to management, and then I have to go slow. Tetris is super hot, right? They made a movie about it. They re-released it for the Switch because of course they re-released it for the Switch again. Real reasons. For Tetris, M-cycle precision is enough. That's good. You only need 284 of the 501 opcodes. Also good. And it's a really small cartridge. We didn't go into details when we started about memory maps, but the cartridge gets mapped into a region that's only 32 kilobytes large. But many games are larger than that. How do they do it? Well, they bank in and out stuff. So that memory banking hardware that's actually in the cartridge, but it has to be in your emulator, because you don't dump that when you dump the cartridge. But Tetris is small enough, you don't need memory banking. So, yay. There's actually very few games who don't use memory banking. If you own a Tetris cartridge and you open it with a screwdriver, you will see there's only one ROM chip in there. That's it. It's very simple. If you then dump it to your computer, which you are allowed to do if you own the cartridge, it's exactly 32,768 bytes large. Perfect. Also, I mean, once you get started, you have Tetris. You could actually do 2-player Tetris. Link 2 Game Boys together, do it in versus mode. That is awesome. I will start working on that as soon as networking is added to the standard. Don't hold your breath. I was promised networking in 20 and 23. It's not coming in 26 either, but go 29, I believe in you. Philosophical question. How do you make sure to win a race? Beat the opponents is good. Be fast is also good, but then you're not sure of winning. Yes? You get rid of your opponents? Be the only one running. By the way, this picture, I think the man deserves some respect. He's called Isaac Makwala. In 2017, the Olympic Committee had him run a qualification all by himself. He passed. Still, guaranteed win. Well, he also had to reach some time limit, but he's... Poor guy. So yeah, why the world's fastest? Well, bragging rights. Also, I told that story. This is a race only I'm playing in. Nobody is trying to make the world's fastest Game Boy Emulator. If you get 59.7 hertz, which is what the screen refreshes at, why would you go any faster? Well, you could run it on low-end hardware. The version I've developed right now runs on the Raspberry Pi Pico quite well. That's good. Also, I want to use it for machine learning. If I want to teach some large language models something useful, like playing games, if I can run my emulator 25 times faster, I can train the machine model for 20 hours in 1 hour, right? So that's good. Also, there's something called the tagline. This is always funny. Does anybody know what the tagline is? It's a word, it's a backronym, it's a word I stole from a work of science fiction. Where's the science fiction fans? No one? I won't tell you. Read more science fiction. Or ask me afterwards. But what did I want to do with the Tagalon? It was a project I submitted. I'm not bitter about it being refused at all. I've been talking about it now for 2 years all over the world. To make fun of my management. I actually wanted to run Tetris on the Game Boy backwards in time. What? Yes. I had a thought experiment. You're walking on a beach and you find a Game Boy frozen in time, and it shows a certain image on the screen, like the image we see right there. The Game Boy does not have true random. So technically, it should be possible, given another Game Boy that you turn on, to go to the exact same state. Same score, same blocks, same everything. How would you do this? The goal of this project, I needed to have something weird to do so I could work with some new C++ and while testing something else, since probably, I'm pretty sure you cannot do this deterministically, running it backward. I was going to have to do some kind of breadth first search, so I needed a fast emulation to check out the results page. It's from a work by Neil Stevenson, by the way. Nobody read Anathem? Yes? And you don't remember the tagline? It's that huge puzzle they tried to make, and only that 1,000-year-old guy managed to do it. Not important. Yeah, also, my emulator will have no sound. Why no sound? Well, no, sound is not very important when you play Tetris. In the long run, I will need it. Is the sound on the Game Boy any good? Well, there's a thing called Little Sound DJ. You see it here in the Game Boy Color version. You see a little name there up here, Patrick. Patrick is one of my not game dev students, but audio dev students. And we have a thing called Crea Week every year where students get projects from the teachers to do something out of the box. And this is a tool with which you can write songs on the Game Boy itself. And this is what Patrick made. See if you recognize the song. Note that he uses only 2 of the 4 available audio channels. So he could actually, if he implemented the rest of the game, he could actually have had space to do sound effects. You all know the game, of course. Yes, no, cancel. It's Doom, of course. All right, so cool, right? Well done, Patrick. It also loops perfectly, but we won't go through it a second time. Sadly, we don't have time. But sometimes sound in games is useful. That's why I might need that in the long run. What does this sound mean? Anybody know that? It sounds what? Like? It means in Zelda you've entered the room where there's a secret to be discovered. So the audio cue there is important, right? If you don't hear this song, there's no secret there. Zelda. The greatest version of Zelda ever. Game Boy version. I will die on that hill. All right. So I need some kind of engine to make this. Back at where I work, we've gone through something called the engine wars. The engine wars are still not solved. But let's say there's a truce. But I discovered this guy's engine, the OLC Pixel Game Engine. What I like about it is it's a single header include, so it's easy to show to students. They just need to include a header. It compiles on Windows, on Mac, on Linux, and into mscripten. I'm sorry, yeah. It actually also has an online playground. It's like Godbolt, but for games. How awesome is that? It's awesome. So yeah, I like that a lot. I want to give a shout out to the original authors. Well done. What does a PG application look like? You inherit from the engine. This should all be pretty standard for people knowing how typical engines work, right? You override some things. In the construction, you actually give the size of the window you want. The two other values you give is multipliers on the pixels. That's also very convenient when you're doing something like the Game Boy, which has a resolution of 160 by 144, right? Original resolution on a modern screen, that's a stamp, right? Tiny stamp, not very good. So a very simple engine to get shit done with. Then I needed to think about what kind of API will I need. I went to talk, we have a research division, and I was thinking, oh, right, the buttons. I have 8 buttons, we'll just pass that a byte, right? Oh no, no, they want 8 bools. But that's not efficient, they don't care about efficiency. That's okay. Okay, so that's the kind of minimal API I would need. If you're wondering why you would have something called getName, actually, if you look at the contents of a ROM, oh wow, that's really bad on that screen, it's worse than I think. If you look at the contents of a ROM, you take a hex dump, the name of the game is actually in there as text, as ASCII text. So it's convenient if you upload the ROM, you can check if it's the correct one by getting the name. Okay. So yeah, this is how you make a bit of an interface, and then this is just some demo code. There's actually that I don't have a lot of time, and there's actually a bug on this slide. The game runs way too slow. Well, too slow, and that'll teach me to make slide code. Can anybody spot the problem? Yes? No? Excuse me? No, the both work. It's not. That's not an issue. It does work, but it's too slow. Performance-wise, it's very slow. The problem is I need a screen refresh of 59.7 hertz. So I need to use 1 over 59.7, not the stupid thing I did right there. There we are. This is what it looks like if you play it. I didn't invent those colors myself. I think they're really cool. I found that online. They're in the slides. If you want to write your own emulator, there are the great colors to make it look like the original and less shitty. The reality is, however, I want you to write the Tetris emulator, right? You don't get smarter. We heard it in the previous talk. You don't get smarter by looking at somebody else write code or having an AI. You have to do it yourself. And actually, this talk quite similar to it, has been given by this weirdo at CppCon. And several people have sent me their GitHubs. So I have seen some interesting code. But I'm still, I mean, if I look at my slides, I'm about halfway through them. I have about half of my time left, so I'm doing good. What are we going to do with the rest of the time? Just go home, have some coffee? No. We need some kind of a toy example. The weird shit I wanted to try, but you can't. I can't show you a full Game Boy emulator, even though it's a nice system, right? I can't show that to you during a talk. So I need something small, a toy example. And now I'm going to try something dangerous. I'm going to go to a website. I have written a script for that, so that should help. Let's try it. Give it some time. that worked. Surprising. Okay, so is it a bit visible? No. Let me first put it full screen. And maybe increase the font a bit. Can you see it a bit now? Yeah, just to show you a bit what it is. So this guy made a website, and on that web, I use it to explain computational systems to my students. Made a website, and on this site you can write some assembly code, assemble it, it gets loaded into the memory of this little computer, and you can run it. The computer also has, right, is based on loosely on an 8080. It has 4 registers, an instruction pointer, stack pointer, some flags, and it has an output, and that output is actually hardware memory mapped to this zone right here, right? And it conveniently also shows you I have assembled this code. It conveniently also shows you, oh, if you talk about loop, it's here. It's of course a typical hello world. Let's change it to hello CppNorth, like so. Let's assemble it. I highly recommend, if you have never played with assembler, it's an important skill, look into it. It's still not very visible on the... Can you read the numbers a bit? Yeah, okay. So it starts with a jump start. So 1F is probably the jump instruction, and 12 will be that label start. Let's see. Oh yes, 12, that's that start. So it jumps over a bunch of stuff. What does it jump over? Well, we just defined some bytes right here. Our hello world is here. Well, that makes sense. 6C twice. That's the 2 L's, I guess. 20 is a space. We know that one by heart. Of course we do. And CppNorth is right here. And there's the null terminating the string. And then there's some stuff. Let's just see it run. Let's see if it works. Let's run through it. You can see it's pushing stuff on the stack right here. The stack is growing upwards. A lot of information gets happening. Oh, I see letters appearing. It's running. And it's going. And going. It's running at a blazing 4 Hertz. I guess that's about the speed you could reach if we used relays, I think. So, but nice. This is a nice little processor, and we can try our IDs on that. If we know something as software developers, it's often nice to try with a little example. This seems to be a nice example. Let's get back to my slides. I'll check my luck and try to activate the thing again. OMG. It worked. So just to show you briefly, right, our instructions were at the top, our stack was at the bottom, growing upwards, and then the last bit of the display is memory mapped. That's where we put our stuff. Let's look at this hardware we are trying to emulate. It's an 8-bit controller. Registers are 8 bits. 256 bytes of RAM, 24 of those are VRAM, 4 general purpose registers, a stack pointer, instruction pointer, 3 flags, and I didn't show you because I don't know, maybe science has gone too far, but you can run this up to 16 Hertz. Little pull down menu there. What instructions do we have? The typical move, which is a terrible name because if you move something, it's a copy. Yeah? You can define bytes, you can add, increment, decrement, multiply and divide. Again, if you do 6502, people who don't know, you cannot multiply and divide on 6502. You have to write a function for it. You can push stuff on the stack. You can do some logical operations like AND, OR, and XOR, and binary NOT, and then shift left and shift right. Call a function which is just pushing a return address on the stack. And then if you call return, it will pop that and put it in the instruction pointer. And there's also conveniently an instruction called halt, which stops the processor. We also have jump. It's an unconditional jump to go somewhere else in the code. Remember the jump start we saw? We can compare things. What will compare do? If you compare two numbers, it will be two registers, usually. You compare them, this will set flags, and then you will have a conditional jump after that. You can add, right? The target operand is always a register. You cannot add something and put it directly into memory. Increment and decrement a register, subtract. Interestingly, if you multiply or divide, you only have one operand. The target operand is always the A register. Question is why? Do you have an idea? Why is it always the A register? No, it's only 8 bits. No, it's just the hardware was like that, right? That's a lot of, if you take the 6502, for instance, all your calculations you have to do with A register. They have an X and a Y too. You cannot do calculations with this one. Just because. That's the reason. Typically, the A register will be the one where you can put results of calculations, because A stood for accumulator. I'm sorry. So these are the valid versions you can do of a move. Interestingly, right? You all understand how a move works? You can move something, one register to another, and that register. Okay, everybody gets this? You're all with me so far? Good, good. I know it. Such a smart crowd. Cppy, look at these smart people. Okay, since you all understand it, which one of those don't make sense? Anyone? Yes? The fourth from the bottom, yes. How could you move a register into a constant? That's insane. Any others? Yes? The middle one has 2 memory locations, right? And we actually saw the 2 problems. The bottom one also has 2 memory locations, and the third one from the bottom is also not good. So these ones make no sense. These are technically not possible. You're a fantastic audience and found all these. Now, why am I showing this? Bytecodes. Assembler, we can't forget this. It's been written to make our lives as programmers easier. People confuse assembler, oh, that's machine code. No, it's not. Machine code is just numbers. Your assembler gets translated into machine code, and your assembler really does work for you. But look, these are all move instructions, but they all have a different bytecode. Why is that? No one? Why do you have to, they're all moves. Why do you have to do different stuff? Yes? Yes. How do you interpret the bytes that follow, right? Clearly that 80 in the first line, that 80 is that 128, right? It's that constant that you want to put in. That 1 in the line under it, that means register B. It doesn't mean put a 1 in there. How could it know it if it had the same bytecode? So we need to keep track of this. I'm going to skip the next slides. You all know regular expressions. If you don't, I have slides about it. Okay. So now we know what we set up to do. Be ready to grind your teeth a bit, because this is going to be terrible code. We do a first naive interpretation. And here we go with the Chrome again. No. Let's give it some time. Yes. So, all the codes I will show is available on Godbolt. I am today wearing my lucky Godbolt socks. That's why I'm wearing green socks. I usually never Were any colors? So let's take a look at this terrible code, right? I just looked up which opcodes I needed. I certainly did not implement them all. Is this a bit visible? Oh, surprisingly so. Okay, that's good. Let's put it full screen. Oh, that's good. So I made a namespace because that's clean, right? And have some memory size, blah, blah, some static, which are my registers. I have my opcodes and an enum class, right? I've given them numbers because they have specific values. I have something to load my program in. And the most important bit of the code, the core of this entire code, is this huge switch, or huge, depending on which value of huge you want to use, right? And depending on the opcode, it does some stuff. It takes stuff from a register or memory or combines them. I've put in some asserts here just to make sure nothing goes wrong. So it crashes if something stupid happens, right? And I have a default, it's an unknown instruction. I'll display it. That helped me while debugging this. I also have something called display state that helps to debug. Also at the end of running a program, I want to see what's on the display and what the values of everything are, right? If I run this program, it shows me what everything and a dump of the screen. I haven't updated the code. It still says, hello, CppCon, I'm sorry. But we'll have to live with this. Because I have to change the bytes, and that's tricky to do live. I have learned not to do such things. But everybody understands this is a very basic implementation, right? Okay. So, but when we were looking at that code, we were cheating against an important rule, the dry rule. This is the first rule of coding. Don't repeat yourself. That switch was full of the same stuff all the time. Funny anecdote. The students I teach don't like the dry rule. They prefer the opposite, the wet rule. Do you guys know the wet rule? It's beautiful. Write everything twice. Also, we enjoy typing. We write every time. We waste everybody's time. So let's fix it. Now, the fix I've done, well, we can take a brief look at it. Again, all the Godbolt links are available. Yes. Here we go. I've actually added exceptions here. Oh, no, just a second. Yeah, so I actually have added some exceptions, right? If some invalid opcode is in the program, it will throw an exception. If your bytecode is weird and you're trying to read something and you're trying to write something to register 7, it doesn't know what that means, so it also throws an exception. Also, right, the opcodes have been, I wrote a little function called getValueParameter that simplifies how everything works. It's not very much better, but it's better code, right? Okay. Okay, just a very brief improvement. There you go. Okay. So I benchmarked them both using QuickBench. Why did I do the benchmark? Because a lot of people tell me, don't use exceptions. Everything will be much slower. Tom, you're crazy. Yeah, I can see it's much slower. Look at that. It's exactly the same. Wow. Well, yes, but it gets slower if you throw an exception. Yes, but that should be exceptional, shouldn't it? Huh? It's my opinion about exceptions. I think exceptions are useful. There's a great talk by Khalil about exceptions for firmware and how a lot of things people believe about exceptions are not true. He also believed them initially, as did I, until he started testing out stuff. And it's not as bad as people think. Okay. So far, we haven't written a class. So probably should do that, right? Should have a CPU kind of class. Let's do that. And, I'm lucky. I don't know when that started, but you can do CMake inside Godbolt, so you can have multiple files. You used to not be able to do that. That's very convenient, right? And I'm gonna show you this. No, I'm not gonna show you this because I'm gonna run out of time otherwise. Just an aside. You all know how to make a class. I'm pretty sure you're very good at this. You should avoid naked for statements. And if you look into that code I show, I'm not the only guy who says that. It's not only the lines. I like this quote by Sean Parent, right? If you want to do anything for code improvement, you have an old code base, just forget everything. Go through your code and have one rule. No more raw for loops. Just that. Just that change will make everything better. Not everything, but a lot. No silver bullet, of course not. Okay, I have this code. To load the program, I pass in a span conveniently, and then I go through it, and I copy that program into memory. Yeah, that's great. And thank you, C++. Because since C++23, I don't need a naked for loop to do that anymore. Look, it's great. Also, it uses structured binding. I love structured bindings. That's great. Now that we have classes, we can do another test. The tests I do are often because things students tell me. Stuff on the heap is way slower. Stuff on the stack is way faster. Using the same class, once on the stack, once on the heap. I will not show you the code. It's just right once I create it with a smart pointer, and the other one just a stack object. It's exactly the same speed. Of course, the object is quite small, but I'm wary of things like don't use exceptions; they will slow everything down. Stuff on the heap is always slow. I don't know. It depends, right? Something I learned from this conference, it depends. Okay. While I was preparing the first version of this talk, it's always like that. Disaster strike, QuickBench stopped working. I never had it do that. It was out actually for several days. So yeah, what do you do? Fine, I'm gonna build my own benchmark. Blackjack, and that other thing that Bender says, and I'm not gonna repeat right here if there's children watching this YouTube. Okay, so I wrote benchmark.h, which allows me to do some benchmarking, just get me some quick numbers. That code, of course, also available. And then we get to what I really wanted to test. Took me long enough to get here, but something I didn't realize until I was not too long ago. Function pointers are const expr. Thank you. Function pointers are const expr. What? Function pointers are const expr. Doesn't that strike you as weird? That's function is sitting somewhere in memory, how can it be const expr? How can you know where it will sit at compile time? You don't even know on which computer it's going to be running. Right? That surprised me. This slide I will skip. Why can it be constant? Because it has to be constant for the linker. The linker knows where it's going to place it. So it's const expr. So I know where functions are at compile time. I can do stuff. Wait, you know what else I can do? You know what else I can do? Have you heard about #embed? I can read files at compile time now. What if I took that ROM, and since I know that bytecode kind of maps to functions, why can't I make a list of those functions, which are just const expr function calls, and call them? That should work, right? For the people who don't know #embed, it's great. It allows you to read in a binary file. It's a preprocessor step. We got this from C, if you can believe it. The guy who wanted to get it into C++ didn't manage to do it, so he managed to get it into C. And since the compiler builders otherwise have to change the preprocessor to behave differently for C++, we also get it officially in C++26. Look what the guy has written a fantastic series of blog posts about it. You should look into it. Look what a beautiful quine you can write now. You embed __ file, which is embedding yourself. So that's then inside this array, and then you print it out. And this works perfectly. Beautiful. So I want to analyze, and I won't go through the dance of going to Godbolt. I'm running out of time because I'm terrible at planning stuff. I want to analyze all these instructions that are in my firmware, in my ROM as bytecode, and I want to make a map. That map will contain where does it sit in memory and what do I need to do. That should be well enough. It's possible. It's possible. You can see I have a templated function there. It's const eval, so I force it to be evaluated well at compile time. If somebody is looking for a cool project, please tools to debug stuff at compile time. The only way I have found to do this is to make it not at compile time, fix it then, and then try again at compile time. But sadly, half the times, because I'm an idiot, half of the times I'm using techniques which are not allowed at compile time. So it's back to the drawing board. Right, but doing all this stuff, I managed to make a map that contains my stuff. Yeah, and it also feels weird when you write at compile time because I needed to know how many instructions are in that ROM. So to do that, I needed to go through it and read every instruction and know how long it was. I also need to have a way to skip parts of that ROM because remember at the very beginning when I showed you that hello world text started after that jump, so I need the way to skip that, not interpret that data as bytecode. So you go through it once to count how many instructions there are, then you know what size your array can be, and then you can put pointers in there, right? So you establish, depending on which instruction it is, what kind of size it is. Also, once you have the opcode, you link these opcodes to the correct methods in your CPU object. And then at runtime, you initialize your map with that data because you can't make compile time maps, but I have all my stuff I need, put that in there, done. Wow. Whole bunch of codes there, not particularly super readable if you're not used to it, but giving some effort. It's not that hard to read, right? Yay. Good idea, Tom. Context per functions, genius. Genius. And all the time, it's not a lot of code, but I put a lot of time in getting this to work. Getting compile time stuff to work, it's not ideal, especially if, like me, you're not used to it. So let's do a test. Yay. After all that work, my new implementation is 50% slower. Great. Great. Maybe switches are very efficient. But, if I'm convinced of anything, is if you make a mistake, you should persist. Maybe I wasn't wrong enough yet. You know what's fucking this entire thing up? It's because I use a map. I should use an array instead. We had to talk about this. Oh, vector was suddenly faster than my... That's what I should do. That's what I should do. So I rewrote part of it, and I'm going to do stuff using an array, and that's slightly more complicated because now I use an array that is too big. In the map, I had locations in the ROM because you have jumps, and I could jump to there, but now I can't do that. So I need to make a too big array, and then not everything's filled out. It's not very efficient space-wise, but I was thinking I'm going to do Tetris, 32 kilobytes. Yeah. Okay. So, yeah, execution with the array is very simple. You can write very compact code. That was actually easy to do. And oh, yes, also on the side, thank you C++20, we can finally do ctat for the size of an array. I don't know why that was so complicated to get in there, but that's very useful because remember what I want to do. I want to do this, right? I want to embed this, but if I have to know the size, fortunately, I can do it with stud2array. Unfortunately, if you're wondering why are the red squigglies there, it's because MSVC doesn't support #embed yet. Well, Clang does, as well as GCC in the meanwhile. So yeah, yay! I did it with an array now. Look, 1 millisecond when I ran this little program, several times, of course, to be statistically relevant, with a certain standard deviation, 4 times slower with the map, yay. And yeah, a huge improvement, but still worse than what I started out with. So, fail. Total failure? Well, these are Godbolt results, which aren't very regular. If I do it on my machine, this is Visual Studio output. What I do get, it's slower, but the standard deviation is always better. I get a smaller standard deviation, so it's more repetitive. In the meantime, I have found an in-between way to use this technique and to make my GameBoy emulator faster. The disadvantage is to do this, you need to compile your ROM into your executable, which make it undistributable, unless you really want Nintendo to come after you. But I can use it for internal projects. Also, I am trying to find some small 32 kilobyte homebrew game that I can use to distribute it for testing. So, failure? Well, half a failure, I guess. I also wanted to know how fast is this running. So I wrote these little nested loops right here. I know it's going to be hard to read. I had to do some trickery because I didn't implement all the instructions. So I needed to be able to do it just with the instructions I had. On my 3.2 gigahertz machine, I can run this 8080 at 250 MIPS, which is okay, I guess. But what do you compare it with? And I was talking about this at the Belgian C++ user group, and somebody says, yeah, but this Z80 code, this should be very much compatible. You should still be able to write this in a modern CPU, and I did. You can write it like that. This is still valid code. This prehistoric code will still run and do the same thing. With minor adjustments, I had to use this offset 0 thingy there. And then I put that in. By the way, this code only works in MSVC and only in 32 bits. Don't ask me if somebody from Microsoft can explain to me why embedding assembly stopped working at 64-bit. They also document it. They tell you it's like that. I don't know why that is. Microsoft. So if I measure this, I get 10,000 MIPS, which is only 40 times faster, right? And this isn't as bad as we would have expected. I'm also impressed, if you think about it. Wow, I get 10,000 MIPS out of my little laptop processor, but of course, it's not accessing memory. It's just doing internal loops with the registers. This is basically a best case for this situation. So this is where I stand now. I have a better implementation of a GameBoy emulator based on techniques I've learned here and what I discovered with assembler, but that's for part 2, and part 2 will not be for today. Before I stop, I have to thank a lot of people. Thank you all for showing up. Thank you also the CppNorth team. This is a great conference. I want to thank my colleagues who always encourage me, my students and former students who are a daily inspiration and also for sometimes a source of frustration, as well as my wife and son who encouraged me to do stuff with this. I couldn't bring all my colleagues, so I've brought them virtually. Look, now you see why I like working there. We're all weirdos. I blend right in. Also, the last slide, and if there's time for questions, this is when I gave this talk, a previous version of this talk at CppCon. I told my son, he was 11 back then. I was really nervous, and there was going to be, just like here, a whole bunch of very smart people, and they might ask very difficult questions. So remember, he's not a native English speaker. On the next slide, I have the tips he sent me. That's my beautiful wife and my son. If you have a hard question, just lasagna. I'm gonna go with number 2. That's it. Do you have any questions? And do I have still time for questions? Everything was perfectly clear. That's how I like it. It worked. Yes.
Yeah. I don't know if you talked to Matt Godbolt or if you saw the talk he made at ACCU earlier this year. I think it's called something like Teaching an Old Dog's New Tricks. And it's basically the same ideas you're looking into, which is making an emulator with like different tech. I wonder how it compares to your approach and if you got some learnings from there.
Yeah, it's funny you mentioned that. He gave the same talk at CPP on C. I was there, and we discussed it extensively. Yeah. It's a related approach, although he doesn't do the compile time stuff. But I'm certainly going to look into his. He did the ZX Spectrum, right? Yeah. I'm certainly going to look into the things he did as well. But working on emulators, I just want to. It's a lot of fun because you get fun results. You can literally play with it when it's done. I recommend the Game Boy because it's so easy. You have something really quick. In a couple of, if you work on it every evening, in a couple of days, you'll be able to run Tetris. That's not that hard. Getting Battletoads to run? You get Battletoads to run, you send me your GitHub, I'll buy you whatever beverage you like. Any other questions, remarks? No? Thank you very much.